Hello students, today in language of chemistry we are going to study the characteristics of chemical reactions. Chemical reactions can show any one type of characteristics. They are change of color, change of state, evolution of gas, evolution of smell, release or absorption of heat, formation of precipitate. Now let's discuss the first one, change of color. Certain chemical reaction shows the change of color with the reactants. Now suppose if we take the iron nail, the initial color of iron nail is silvery white. But when it undergoes the reaction, that is in presence of moisture and oxygen, it changes its color to reddish brown. Okay, that is the change of color. One more example what we can take is if you take copper carbonate. Now this copper carbonate is pale green in color. Okay. So when I heat this copper carbonate, what I will get is copper oxide, which will change its color to black plus carbon dioxide. So these are the examples which will come under change of color. Second one is change of state. Now certain chemical reactions take place with the change of state. That is, suppose if we want water, then we can take hydrogen, which is in a gaseous state, and oxygen, which is in a gaseous state. That is, in presence of electric current, what we will obtain? Will obtain water which is in the liquid state. So this undergoes the change of state. That is, the gaseous thing is getting converted into the liquid state. One more example what we can take is ammonia gas. When it comes in contact with HCl gas combines, and what you will get is ammonium chloride, which is in the solid state. So these are the examples which will come under change of state. Third one is evolution of gas. Now, what do I mean by this evolution of gas? Certain chemical reaction take place with the evolution of gas. That is, the gas is being evolved out in the form of bubbles. Okay? So when a gas is evolved out in the form of bubbles, we call it as effervescence. Okay, that is the evolution of gas in the form of bubbles. Now here in this also we can take an example, zinc metal. When it comes in contact with HCl acid, hydrochloric acid, dilute one, what we will get is zinc chloride, and you can get to see the bubbles, you can get to see the effervescence, that is hydrogen. Okay. So here this hydrogen will come out in the form of bubbles. So this is the example of evolution of gas. One is evolution of smell. In certain chemical reaction, a specific smell is obtained. Okay. When sulfur is heated with the hydrogen, you will get to obtain the foul smell of hydrogen sulfide. So that is the example which will come under the evolution of smell. Fifth one is the release or absorption of heat. In certain chemical reaction, heat is either absorbed or heat is released. Okay. So in this absorption or release of energy, we have two different types of reaction. One is exothermic reaction. Exothermic reaction. It is a reaction in which the heat energy is given out or heat energy is evolved out or the heat energy is released. We call it as exothermic reaction. So in this exothermic reaction, we can take an example, that is burning of magnesium ribbon. So when magnesium ribbon is burned in presence of oxygen, we get to see the light and we obtain heat. So here this reaction proceeds with bright white dazzling light. So after this we get the white ash, that is magnesium oxide. One more example what we can take is the reaction between ammonium hydroxide and hydrochloric acid. So the reaction proceeds with the evolution of heat. So these are the examples of exothermic reaction. And the next is absorption of heat, which we call it as endothermic reaction. Now what do you mean by this endothermic reaction? The reaction in which the heat energy is absorbed or the heat energy is taken in, we call it as endothermic reaction. So in this endothermic reaction, we can take an example, that is ammonium chloride. Now ammonium chloride, when it is dissolved in water, it will absorb the heat and it will make the container fill cold. Okay, so that is about the release or absorption of heat. Sixth one is formation of precipitate. Now basically in chemical reaction, it leads to the formation of precipitate. Now what do you mean by this precipitate? Precipitate is an insoluble solid mass, okay, which is being formed during the reaction. So here let's take an example for the formation of precipitate. Suppose if I use copper sulfate and if I mix it, that is a solution, okay. So this solution, if I add it in sodium hydroxide, I'll get to obtain copper hydroxide. Now this copper sulfate is blue solution, blue in color, and the precipitate, what I will get will be the pale blue precipitate. Pale blue precipitate. Now always remember that precipitate is denoted with the downward arrow, okay, and the other what we are going to get is sodium sulfate. Let's take one more example. Suppose if I take barium chloride plus solution plus dilute sulfuric acid, you will get the one precipitate, that is of barium sulfate, BaSO4 plus HCl. Okay, so here you will get white precipitate. So in this we have studied the characteristics of chemical reactions, and that change of color, change of shape, evolution of gas, then evolution of smell, release or absorption of energy, and the formation of precipitate. To study chemical equation, the representation of chemical reaction using symbols and formulas of the reactants and the products, we call it as chemical equation. Okay. Now, the chemical reaction, when it is represented with the name of the chemical, then we call it as word equation. Okay. Now, in this chemical equation, we have to remember that there are two parts. That is, one is left hand side and one is right hand side. Always remember, reactants are written to the left hand side and products that are obtained are written to the right hand side. Okay. Suppose if we have more than one reactant, then it is connected with the plus sign. So let's take A and B. Since the reactants are more than one, it is connected with the plus sign. Same way, whatever the products we are going to obtain, if it is more than one, then it will be connected with the plus sign. Okay. So now this arrow is written. Now basically this arrow is meant for the condition. If any conditions are required, for example heat is required, temperature is required, then the condition can be written on top of the arrow or below the arrow. Now suppose, let's take an example, burning of magnesium ribbon. Magnesium ribbon. Now for burning of magnesium ribbon, we require magnesium, okay, plus we require oxygen. Now for oxygen, we cannot write it as O because these are the molecules, okay. This is considered to be the monoatomic molecule. Oxygen, hydrogen, nitrogen, chlorine, these are all diatomic molecules. So all these gases, oxygen, hydrogen, nitrogen, chlorine, bromine, this has to be written as O2, N2, H2, Cl2, Br2. Okay. So after this reaction proceeds with the heat. Some amount of heat is required. Okay. Wherein what we get is magnesium oxide. Now these are my reactants. Since it is more than one, it is connected with a plus sign, and here I have obtained only one product. Now I need to check whether this equation is balanced or not. Let's start with magnesium. Okay. Now here magnesium is only one atom. Okay. And over here it is one atom. Oxygen is two atoms over here. But oxygen over here is only one atom. So is this equation balanced? No. When the equation is not balanced, we call it as skeletal equation or unbalanced chemical equation. Now always remember that we have to balance the equation. That is the left hand side. Now reactant side, this is your left hand side, should always be equal to the right hand side. Why? Because according to the law of conservation of mass, the mass can neither be created nor destroyed in any physical or chemical change. You all have already studied this law of conservation of mass. So whatever the number of atoms are there to the left hand side should be equal to the number of atoms that is present to the right hand side. So now magnesium is 1, your magnesium is 1. So magnesium is balanced. Now what about oxygen? Oxygen is 2, but over here oxygen is 1. So how you are going to make it as 2? Remember, when you have to change the number, you cannot able to change the formula. Formula will remain as it is. Okay? Only thing, whatever number you have to add, you are going to put it in the coefficient. So I will put 2 over here. So when I put 2 over here, oxygen becomes 2. Now this 2 is applicable for magnesium also. But over here magnesium is 1. So how I can make it as 2? Magnesium is 2, oxygen is 2. Oxygen is balanced. This is 2. Over here also it has become 2. But magnesium over here it has become 2. So how I am going to balance this, or how I am going to make it as 2? So for that I can't change the formula. Okay, it will remain as it is. But I can put the coefficient 2 over here. So magnesium is 2, here also magnesium is 2, oxygen is 2, here also oxygen is 2. Now the equation is balanced. So once the equation is balanced, that is the left hand side when it is equal to the right hand side, we can say it as the balanced chemical equation. Okay? In this I have taken some examples and you are asked, write the word and skeletal equation. Word equation is whatever you are given, you have to write it in the word form, and what products you are going to obtain, that also you have to write. So let's start with first one, the reaction of sodium and hydrochloric acid. So I write sodium plus hydrochloric acid gives, I'll write the formula also. Sodium is Na, okay, and when it combines with hydrochloric acid. Now what is the formula of hydrochloric acid? It is HCl. So when sodium combines with hydrochloric acid, what I will get is sodium chloride. Okay, so I'll write it over here, sodium chloride plus what I will remain with, hydrogen. So I'll write it as hydrogen. Now I'll write the formula, sodium chloride. Sodium chloride is NaCl. Sodium chloride is NaCl, and hydrogen, as I said, hydrogen is a diatomic molecule. So whenever you have hydrogen, nitrogen, oxygen, chlorine, then you have to write H2. When you have nitrogen, you have to write N2. When you have chlorine, you have to write Cl2. Okay, oxygen you have to write O2. Now, since we are asked to write the word equation, we have written the word equation. We have written the skeletal equation also. Now, we have to check if the equation is balanced or not. Let's start with the first one. Sodium, it is 1. Here also it is 1. So, sodium is balanced. Check for hydrogen. Hydrogen is 1, but hydrogen over here is 2. So, how I can make it as 2? This side it is 2 and this side is 1. So, I have to change it over here. So, how I can make it as 2? I will put a number in front wherein the hydrogen will become 2. So, here also hydrogen is 2. As I have said, this 2 is applicable for hydrogen and the 2 is applicable for chlorine also. So, chlorine has become 2, but over here chlorine is 1. So, how you are going to make it as 2? Yes, you are going to put the number 2 in front. Okay, as I have said, you can't able to change the formula. You can't write it as NaCl2. No, already the formula is given, that is NaCl. Whatever changes you have to make it in front. That is only the coefficient will change. So now once I put 2, this 2 is applicable for sodium also. 2 is applicable for chlorine also. Chlorine is balanced. Hydrogen is balanced. Chlorine is 2. Here chlorine becomes 2. Now what about sodium? Sodium is becoming 2 and here sodium is 1. So how you are going to make it as 2? Yes, you are going to put the number 2 in front. So now let's check again. 2 sodium, 2 sodium, 2 hydrogen, 2 hydrogen. This is fine. Okay. Then 2 chlorine and 2 chlorine. So now you can say that the equation is balanced. Always remember, just try to put the numbers over here. Okay. Whenever you are balancing, just check the number. 2 sodium is 2. So here also 2. So this sodium is balanced. Then check for hydrogen. Hydrogen is 2. Hydrogen over here is also 2. The same equation you can balance it in a tabular column. You can just draw the tabular column and you can just write the elements involved in this. So let's count the number of atoms to the reactant side. Sodium is 1. Product side, sodium is also 1. Hydrogen, reactant side is 1. Product side is 2. Chlorine, reactant side is 1 and product side it is 1. Now, sodium is balanced. What about hydrogen? Hydrogen, the reactant side is 1 and this is 2. So, you have to increase to the reactant side. So, how you are going to make it as 2? Yes, you are going to multiply by 2, so that will become 2. So here I'll put a number 2. So when I put a number 2, 2 is applicable for hydrogen also, 2 is applicable for chlorine also. So hydrogen is balanced, here it is product side is 2, reactant side is also 2. But as I have said, this 2 is applicable for chlorine also. So to the reactant side, it is changing from 1 to 2. But to the product side, it is only 1. So how are you going to make it as 2? Yes, you are going to multiply 2 so that it will become 2. So I will put the number 2 over here. So when I put 2, it is applicable for sodium, it is applicable for chlorine as well. So sodium to the product side, it is becoming 2. But to the reactant side is 1. So you need to balance to the reactant side also. So how are you going to balance it? You are going to put the number 2. So sodium to the reactant side is also 2. So let's check again. Sodium to the reactant side is 2. It is 2. To the product side, sodium is 2. Here also I have put 2. Hydrogen to the reactant side is 2. So it is 2. And hydrogen to the product side is also 2. Chlorine is 2. And chlorine to the product side is also 2. So you can say that this equation is balanced. So you can either write the equation in this form or else you can follow this method. Let's go for the second one. Reaction of hydrogen and chlorine. So hydrogen, as I have said, These are the diatomic molecule. So it will be H2. Sorry, I have to write it first as a word equation. So hydrogen plus chlorine. When hydrogen and chlorine combines, what we get is hydrogen chloride. Hydrogen chloride. So now we have to write the equation. So hydrogen, as I have said, is a diatomic molecule. So it will be H2 plus chlorine is also a diatomic molecule. That will be Cl2. Hydrogen chloride is HCl. Now you have to check whether the equation is balanced or not. Hydrogen is 2. Hydrogen over here is 1. So how you are going to make it as 2? Yes, you are going to put the number 2 over here. Now this 2 is applicable for hydrogen. It is applicable for chlorine also. Now let's check for chlorine. Chlorine is 2 over here. Here also it is 2. So you can say that the equation is balanced. Okay. Let's solve the third one. Reaction of calcium and oxygen. So I'll just write calcium. Calcium is monoatomic molecule. So it is just Ca plus oxygen. It is a diatomic molecule. So we have to write it as O2. What we will get? We will get calcium oxide. Okay. So let me first write the word equation. Calcium plus oxygen will give calcium oxide. So now let's write it in equation form. Calcium plus oxygen. What we will get is calcium oxide. Now we have to check if the equation is balanced or not. Calcium to the left hand side is 1. To the right hand side is also 1. Oxygen to the left hand side is 2. But oxygen to the right hand side is 1. So how you are going to make it as 2? Yes, you are going to put a number 2. So when you put a number 2, this 2 is applicable for calcium also. 2 is applicable for oxygen also. So calcium is becoming 2. So how am I going to make it as 2? Yes, I am going to put a number 2. So 2 calcium, 2 oxygen, 2 oxygen. You can say that the equation is balanced. So in this we have studied the chemical equation. We have studied how to write the word equation and how to write the skeletal equation. Please practice this reactions, how to write the word equation and how to write the skeletal equation. And after writing the skeletal equation, please try to balance the chemical equation, because we have to always balance this chemical equation according to the law of conservation of mass. Okay. So in this we have completed the language of chemistry chapter. Thank you.